So next, we've gotten input impedance already. So the next thing to do is our gain. What will be your gain? So gain equals output voltage over input voltage. Of course, is what we said to be AV. Okay, so here we already have our output voltage as these guys RC. We already have this as our output voltage, and then for our input voltage we have it as, let's go back to our diagram, okay, we've not calculated for input voltage, but we can do that now. We can do that. So for the input voltage, of course, is this input voltage. The resistance, these are total resistance. Okay, these are total resistance. Then for the current is what? Our current is the base current, IB. So since these are total resistance here, these are current here. So it will be this times this, because voltage equals current times resistance. So this times this is our input voltage. So we just have to place it somewhere. I think I should do that before this. Good. Bring this down. So for input voltage equals base current multiplied by beta IB. Really? No. What's there? Beta RE. Yeah. Beta RE. Beta RE. Okay? So when we say gain, output voltage, which is these guys, over input voltage is these guys. So of course we've written output voltage as this, input voltage we are going to write all this. Let me just copy it. Input voltage. Input voltage. Copy. Do you copy? Okay. Voila. So you know now, cancel. This cancels this, and this cancels this. So what's left is gain. Which will be your gain? AV equals minus RC all over RE. That is your gain. Keep this somewhere, don't forget it. Okay, remember it. Recall. Okay, so we've gotten output voltage. What is left is current. Okay, we've gotten our gain for current. We don't gain current. So we've gotten the gain for voltage. So for current, okay, of course the gain for current will be output over input. So we have to look for output current and input current. Okay, so let me put this for current, and then for what? Let's start with output current. For output current, okay, now to get our current we need to make use of the current divider rule. Okay, so for input current now, let me go to the circuit. Let's go to the circuit diagram, the model. Now, using the idea of current divider rule. Now, the idea of current divider rule. First of all, we are looking for the output voltage. Output current. So we'll deal with this part. Okay. So and of course, the output current IO equals. Now, the output current RO. How we do it is this. I'll start with the denominator because it's quite simple to explain. just sum the resistance you have in this network. So you will say RO plus RC. Okay, so the current we are looking for is IO, right? So that place, the resistor RO, you will take it and then you multiply it by the total current. Done. Of course, total current is IC, and we said IC is what? Beta IB. So we have beta IB there instead. Beta IB. Okay, so you take this out of this place. So we'll copy this down, or we'll cut rather. Good. Of course, we can express this as IB equals beta RO plus RC. Okay, we just brought this guy down. Okay, now for our input current, same pattern, but instead of calculating for the input current, we'll calculate for this guy, because we calculated from this direction. Okay, so we'll calculate from this direction. I'll tell you why later. Okay, so let me just say it now, because in this calculation we had RB IO over RB. So in this calculation too, we still need the RB so that they will cancel out. Then we can have our IO over IA. Let's just continue the solving here and you will see what I'm talking about. So in this case now, RB, right? So RB, no, not RB, please, IB. No, just look me like that. Okay. Now IB equals what? Same pattern, current divider rule. Sum all the resistance here, which is RB plus beta RE. Good. Then the resistance in this IB, RB, of course, total current II. Done. So we pack these guys. Okay. Good. Of which we can write as IB all over I, yes, equals RB all over RB plus beta RE. Okay. Now we can see, you see now we have this. Okay. This. So okay, then now I can say for gain or current gain, which is we can now say current gain, of course, that is this guy, equals equals I out over I in. And we can express this as saying, this here multiplied by this. Okay, now it makes sense because IB can cancel out IB, so it's the same thing as IO over IA. Now it makes sense. Okay, so we can just write out what is I over IB. Come here, you pack it, so you collect it, and you place it here. And then what is RB over, what is IB over IA over II? All this, you bring it here. Good. Good. Now, of course, RO, I think we've said this before, that RO is far greater than RC. Okay, RO is far greater than RC. Also, ROB is far greater than RE. And of course, like I said, it's just like having a drop of water in the ocean. The drop of water means nothing. So that means this equals beta RO all over RC. Okay, all over ROs, sorry, because RO is greater than RC over RO. Okay, then RB, BRO, brother, RB all over RB, since RB is far greater than beta RE, and of course this will cancel out. So this is what we have left. In fact, this will even cancel out, and that means the gain, what see we gain now, beta. Okay, AI is beta. AI is beta. AI is beta. Okay, so I guess this is it. We now have our current gain and our voltage gain. But if you want to say, if you want to check, have your voltage gain or your current gain divided by the voltage gain, this is just like saying we have beta all over. Remember, our voltage gain is what? Our voltage gain is negative RC all over RE. So that will be, of course, when we have it under like this, it will work. Okay, let me just put it out here like this. Divided by negative RC all over RE. Okay, so of course when we switch this division sign, beta, when it becomes multiplication, we have it as negative RE over RC. Okay. Oh guys, please pardon me for this. So at some point I use small letter, at some point I use capital letter for this RC. Please pardon me for that. I can't really go back and delete everything. So just know that it's the same. Okay, should have been, just please, thank you. So this will now be negative beta RE over RC. Okay, and of course beta RE, we know that is a impedance in. That's impedance in. So we can even say this is a negative impedance in all over RC. You can say this. Okay. All right. Now, this negative sign just kind of indicates a phase shift. Like I said, it's in the opposite side. So kind of opposite. So it will be like 180 degree shift, that kind of thing. Okay, so yeah, this is all for this video, and I guess this is all we've done for now. Okay, so I hope this helps. I know it's kind of really much, and I hope it's not that much. So just I hope it's okay. Okay, I hope it's okay. So just take your time, slow down. You can just watch the video for some maybe for some time, for some minutes, you stop, you start again. Like, you must not consume everything at once. But if you can consume everything at once, go ahead. Okay, run it, go ahead. But if you can't, if you have to take some time, do take some time and go through this stuff. So really thanks a lot for watching, and subscribe, like, share, click on notification bell, and I'll see you all in the next video. Seriously, thank you all for watching. Bye for now.